There are some phenomena in light like as reflection, refraction, diffraction, in polarization and interference, which can be explained on the basis of wave nature of light. But there are some phenomena in light observed like as photoelectric effect, Compton effect, Raman effect, Zeeman effect and Stark effect, which cannot be explained on the wave nature of light. To explaining these phenomena of light in 19th century, Max Planck proposed quantum theory. According to quantum theory, light travels in the form of discrete packet of energy which is known as photon. Photon is the quanta of energy. So, according to according to Planck quantum theory, light travels light travels in the form of discrete packet of energy, discrete packet of energy is called quanta. One quantum of radiation is known as photon. One quantum of radiation is known as photon. When radiation interact with matter, then it behaves that it is made up of particle. In the interaction of in the interaction of radiation with matter, it behaves as a particle. Called photon. Planck observed that when radiation interacts with matter, then it behaves as particle. So, photon is also called particle, energy of particle. Hence, it behaves particle nature. Energy of a photon is dependent on its frequency of photon. The energy of the photon is directly proportional to frequency of photon or light. That is, energy of the photon is proportional to frequency of photon nu. E proportional nu or E is equal h nu. E is equal h nu. This is the formula for energy of a photon, where nu is equal frequency of the photon, h is Planck constant, and the value of Planck constant is equal 6.62 times 10 power minus 34 joule second. The value of Planck constant is equal 6.62 into 10 power minus 34 joule second. So it is clear from this formula the energy of different photons are different. If the frequency of a photon is known, then its energy can be calculated by this formula. Photon travel with light velocity. Photon travels with light velocity. That is, c is equal nu lambda, where c is the velocity of light, where c is equal velocity of the light, its value is equal 3 into 10 power 8 meter per second, and lambda is wavelength. Lambda is equal wavelength of the light. C is the velocity of light and lambda is wavelength of light. So velocity of the photon is given as c equal to nu lambda. If c equal to nu lambda, then we can write on place of nu is equal c by lambda. Putting this value of nu in equation first, we can find out energy of photon in another form. We can find out energy of photon in another form. Putting the value of nu in equation first. From equation first, energy of photon is equal Sc by lambda. This is equation third. This equation implies that energy of a photon is inversely proportional to the wavelength of light. Due to increasing frequency, the energy of photon also increases. But when wavelength of light increases, then energy decreases. If graph is plotted between energy and frequency or wavelength, then graph are often as below. If graph is plotted between energy and frequency, taking energy on y-axis and frequency of the photon on x-axis, taking energy of photon on y-axis and frequency of photon on x-axis, then a graph is obtained. A straight line is obtained which represents that energy of photon is directly proportional to its frequency. But when graph is plotted between frequency and wavelength, taking energy of photon on y-axis and wavelength of the photon on x-axis, then graph is obtained as below. That is E proportional 1 by lambda. So it is clear, due to increasing frequency, energy of photon increases, but due to increasing wavelength, energy of photon decreases. The rest mass of photon is 0. The rest mass of the photon is 0. The rest mass of the photon is 0 if dynamic mass of the photon is m, then its momentum P is equal mc, where m is the dynamic mass of the photon and c is velocity. According to Einstein, mass energy relation, according to Einstein, mass energy relation E is equal mc square, or E is equal mc into c. From equation 4, putting the value of mc, so we obtain from equation 4 energy of the photon E is equal Pc. So energy of photon can be obtained in three forms. If frequency of the photon is obtained, then we can calculate energy. If wavelength of the photon is obtained, then we can calculate energy of the photon. And if the momentum of photon is given, then we can also obtain energy of the photon. So energy of photon is equal to Pc. But we know that energy of a photon is equal h nu. H nu is equal Pc, or momentum of the photon P is equal h nu by c. P is equal to h nu by c. So if the value of frequency of a photon is known, then we can obtain. its momentum. But if we write, since we know that E is equal the momentum of the photon, P is equal h nu by c. Since we know that E is equal to h nu or E is equal to s c by lambda. So if we can write from equation 5, from equation 5, if we put value of energy E, so Sc by lambda is equal Pc. So C to C cancel, or momentum of the photon P is equal h by lambda. This is equation 7. So these are formulas by which we can calculate energy and momentum of a photon. If the wavelength of a photon is known, then we can calculate its momentum. That is P is equal to h by lambda. For example, if work function of a metal is, if work function of a metal is 3.31 electron volt, then calculate the value of frequency of light. Since we know that work function W, work function I naught is equal H nu naught, here sorry, then calculate the value of threshold frequency nu naught. Since we know that the work function for a metal phi naught is equal h nu naught, or nu naught is equal phi naught by h. Phi naught is the work function for metal which is given 3.31 electron volt. Since 1 electron volt is equal 1.6 times 10 power 19 electron volt. Hence, the value of work function which is given 3.31 electron volt. So this can also written as 3.31 into 1.6 into 10 power minus 19 by 6.62 into 10 power minus 34. So This can also be written as 1.2 into 1.6, 1 by 2 into 1 by 2 into 1.6 times 10 power 15, or this can also be written as 0.8 into 10 power 15, or this can also be written as 8 into 10 power 40 hertz. So, value of threshold frequency for given matter is often 8 into 10 power 14 hertz. Similarly, another example is given as to calculate energy and momentum. To calculate energy and momentum of the photon when wavelength is of the photon is 4000 angstrom. Here we see that in this question, wavelength of the photon is given. So we can calculate energy and momentum of the photon. Since we know that 1 angstrom is equal 10 power minus 10 meter. So 4000 angstrom is equal 4000 into 10 power minus 10 meter, or 4 into 10 power minus 7 meter. Since energy of the photon is equal h c by lambda, so putting value of h and c in this equation, putting value of h 6.62 into 10 power 34 and value of c 3 into 10 power 8 divided by wavelength lambda 4 into 10 to power minus 7, and this can also be written as 19.86 by 4 into 10 to power minus 19, and this is equal to divided 19.86 by 4, we can obtain across 4.96 into 10 to the power minus 19 joule. And also we can find out momentum. Since momentum of photon P is equal h by lambda, or P is equal 6.62 into 10 power minus 34 divided by 4 into 10 power minus 7. So this is equal to across to 1.65 into 10 power minus 27 kilogram meter per second. Hence, putting the value of Planck constant h and value of wavelength of light lambda, we can calculate value of momentum. The energy of photon is measured in electron volt. Generally, energy of the photon is measured. Energy of the photon is measured in electron volt. 1 electron volt is equal 1.6 into 10 power minus 19 joule, and the bigger unit of the energy of photon, kilo electron volt and mega electron volt. 1 kilo electron volt is equal 10 power 3 electron volt, and 1 mega electron volt is equal 10 power 6 electron volt.